Okay, so today we are going on with our matrices, but we're going to look at different things like communication matrices and also which involve using networks, okay? So what a network is a set of objects that are connected together. It can be objects or it can actually be like tasks. You know, they might say this is a task and, you know, the company has a few tasks to do. So you've got like a center and then they're connected in some way. So say, for example, sometimes we say a network of towns. So say we're out and there was a network of towns. So you might have like town A and then there's a road connecting to town B, and then you might have town C and there might be, say, 2 roads connecting between A and C and things like that. So this is like an example. That's what a network is. So we've got objects. So the objects are like the A, B and C, and we're connecting it in various ways. Okay, so what we call these, just briefly, we will do the topic of networks later, but we just need to know a bit briefly. So these are called the vertices. Okay, so those are the vertices, and the lines in between are referred to as the edges. Okay, so that's how we'll see. We just at the moment, we just need to know what are the basic terms of a network. All right, so we can see here they've drawn a network diagram on the right and the roads connecting between the 3 towns A, B and C. So it says use matrix to represent the road connections and each element. So we've got the explanation there in your notes, but I'm just going to go through it with you. Okay, so when we're setting up a network of a matrix for this network. So here is, we've got a network being given to us. Now, if you count up how many vertices, or in this case, they're talking about towns. So how many towns do we have there? 3. Good. So when we do a connecting matrix to this, we're going to have a 3 by 3. So what we're going to say is we're going to have A, B, C, A, B, C. And what you do is, if there's a path connecting those like towns together, you count it as 1. So if you look, for example, is there any like path that's going A back to A? There isn't there? There's no little loopy ones, and that's why they've got a 0. We put a 0 there. Now, if you look from A to B, how many lines are going from A to B? Is there 1? So we've got 1 line going from here to here. Can we see that? Sorry. Okay, I'll just keep going. So there's 1 line between A and B. So between, up on that top row in the middle, you're going to see a 1 between the A and the B. And you'll also see it down underneath. Say row 2, column 1, you'll see a 1 there because there's a 1 in between the A and B. Okay, so we've seen, we've got a 1 here, and then there's no paths between A and C, and so we're going to put a 0. Now B and B, B to B, didn't have any paths. Now, how many roads are there between B and C?
1.
How many? Yeah, we've got 2. We've got 1 and we've got 2. So that's why that one's a 2. And you can keep going. So there's none between A and C. C and B, there's 2. So you'll see another 2 there. And C has 0. So that's how what you're doing is to set up. And this is a matrix. A network matrix. So it's showing you the network in matrix form. So you'll notice it is always going to be a square. So when you have a network and you're setting a matrix up, it'll be a square. So how many vertices you have. Right. So let's keep going. So here, let's have a go at doing this one. The network diagram on the right shows roads and connections between 4 towns. A, B, C. Use the matrix to represent the row connection. Each element should describe the number of ways to travel directly from one town to the other. So what order will my matrix be that I'm going to...
4 by 4.
Good, a 4 by 4. I'm going to pause it and let you guys have a go, and then I'll come and... Alright, I'm going to keep going now. So we will need a 4 by 4. So I would write out the towns, A, B, C, and D, and then the same across the top. I'm going to see like that. Now, there's no looping, so I'm going to be quick and just go down the diagonal, because the diagonal is all the ones going back to itself, and I can see there's no little loops. If you were to have one, just to show you, when you have one going to itself, say there's A, there's B, what you see is this, yeah? You see like a loop like that. That's when it goes back to itself, all right? So but we don't have any like that at the moment. So let's keep finishing. Between A and B, there was 1. Between A and C, there was 0. And between A and D, there was 1. Between B and A, 1. B and C, 1. And B and D, 1. C and A, 0. C and B, 1. And 0 between C and D. A1, D has 1, and 0, 0. So did we all get this matrix?
Yeah.
All right, good. Now the next part of the question is, it says, what information is given by the sum of the elements in column D? So column D, here's column D, okay? And what does the word sum mean?
Total.
Sum means...
Add.
Yep, good. It means add them up. So if we added all them up, 1 plus 1 plus 0 plus 0, what does that, and gives 2, what does that tell me?
2 ways to travel.
Yep, 2 ways to get into town, or travel out from town D, yeah? Okay, so 2 roads are leading into town D, so we might write that. 2 roads, like leading out or in to town B, D, sorry. Okay, so now we're going to look at communication matrices, and so at the beginning we're just going to look at communication and connections. So a communication matrix is what, it has a special name, it's called binary. Binary means it only has 1s and 0s. So if you want to put an example, it'd be like, you know, like that. Yeah, we'll only see 1s and 0s. And it can be used to show how people can connect with each other. So if you have a look here, we've got an example here is a network, a social network, and we might just say, this is how these people communicate with you. So this is a social network diagram that they've given you here. Now, if we convert that to a communication matrix, so we're gonna still be a square matrix. It's sort of like what we were doing before, but once you communicate, you can communicate. So there's not going to be multiple ways of communicating. So that's why it's only a 1 in between. There's never be 2 paths in between 2 people. So if we do the same, and I'm just going to go Vicky, Stephen, Kathy, and Paul, and Vicky, Stephen, Kathy, and Paul. Now, it's a good point to bring up. If you notice, so if you have a look here, you've got to make sure, see how I did that order of people. It doesn't matter if you do a different order, like say you put Kathy first, as long as this order is the same as that order across there. Okay, so that needs to be the same order. Whatever you're going to say first, it has to go the same way across there. Okay, so if we go through, obviously we're going to say you don't need to communicate with yourself. You already know the message. If you think about, we were getting a message to the people. So Vicky can talk to Stephen. So there's a 1 between Vicky and Stephen. Now Vicky can talk to Kathy, but she can't talk to Paul. So we'll do that. And then we can go through again. So Stephen can talk to Vicky. Stephen can actually talk to Kathy, and they can talk to Paul. Kathy can talk to Vicky, Stephen, and Paul. And Paul can't talk to Vicky, but can talk to Stephen and Kathy. So there we go. There's a way of practicing setting up a communication matrix. It's only going to have 1s and 0s. That's a binary matrix. If you remember, have you heard about in computers how when they talk about binary coding? And I'm pretty sure that means you only have 1s and 0s in the coding. That's why it's called binary coding. All right. So this one's a little bit small, but let's go through it. So we've got another example here. It says, Eva, Wong, Yummy and Kim are students who are staying at a backpackers hostel. Because they speak different languages, they can have problems communicating. The situation they have to deal with is that here. And it's got Eva only speaks English only, Yummy speaks Japanese only, Kim speaks Korean only, and Wong speaks English, Japanese and Korean. So conveniently, this information can be summarized in a network diagram. So this one is the network diagram, okay? And they said the task is to construct a matrix, communication matrix. So we have to go through this. So if you have a look, let's go through it. We're going to put a 0. Eva's not going to talk to herself. But who can she talk to? If you look at the network diagram, who can Eva connect with? Wong. So we'll see a 1 there and a 0 on the other ones. Okay? And then we've got Wong can actually speak to everyone, but not going to bother talking to themselves. So Wong's that. Yummy can only talk to Wong. And Kim can only talk to Wong as well. So there we go. We've set up a communication matrix. What this is actually called is a 1-step communication matrix. Okay, so what we mean by 1 step, it means you can directly get that message. Who can you talk to directly? So 1-step communication matrix. Okay, so when you're talking about who can directly talk to each other, that's called 1-step communication matrix. This is called, so a 1-step communication link is when communication can occur directly between 2 people. So we've shown you here, here's the 1-step communication matrix. Now, we are also going to look at 2-step communication. So 2-step communication means how can I get a message and I'll do it in 2 steps. So if you had a look at it, say for example, if Yummy wanted to get a message to, say, Eva, Yummy had to go to Wong and then to Eva, yeah? So this is this is one example of a 2-step communication between Yummy and Eva. Okay, so that's what 2-step means, when you give it the message to someone else who gives it to it, and it's done in 2 steps. So you can see the 2 arrows there. Okay, now so we can find the 2-step communication matrix. So the way we do it is we get the 1 step and we raise it to the power. So here is 1-step communication of that scenario. And now we've got 2-step. We just raised it to the power of 2 on our calculators. And then we've got the 2-step. So if you have a look, if you have a look at our little example we just did over here, where we said we were talking about the Yummy to Eva in 2 steps. There was one scenario of that. So if you actually go down to Yummy and look at Eva, what did I say? Yummy and Eva. Wait a minute, this could be so. Just in summary, to get the 2-step, we just have to set the 1 up and square it on our calculator, okay? And if they ask us, sometimes they ask us to tell us how many there's 1 and 2, and we'll combine, but we'll have a go at some examples. All right, so when they talk about these communication matrices, that diagonal, the one on the diagonal, we call it a redundant link. What does the word redundant mean?
Like no more.
No more. It's not really useful, not good. So why would the diagonal, why is it redundant? Why are we really not really interested in that one along the diagonal? Yeah, but why is it not needed? What's happening in that scenario? Yeah, no? Yeah, it's the option of whether you're talking to yourself. So whether it's 1 or 2, who cares? I don't want to send a message out just to come back to me. So that's why we're saying redundant. So they will see, so you will see that. So that's important to see. All right, let's go here. When people communicate directly with each other, we say there is a 1-step communication link. When people can communicate indirectly with each other via another person, we say that's 2-step communication links. So it says, consider the situation before. So here they've connected, they've written out 1 step here. And this is just who can directly talk to each other. Then they've squared that and they've got this thing. Okay, so let's have a look. If we have a look at, I'm going to have a look at one of the numbers. So I'm going to look at this number here. This says that there is 2 2-step communications. I might say 2 options of 2-step communication between A and D. So let's go and find them in the original. How could A get a message to D in 2 steps? We start at A.
A to B.
Good.
B to D.
We could go A to B, B to D.
Same as
That's
C.
one option. And then they're saying there's 2. So what's the other one? I'd have to start at A and I want to get to D, but it has to be different. So what could I use?
A to C.
Yeah, A to C. And that's why there's 2. That's why there's a 2 between that, because there's 2 options of 2-step communication. Okay, in the diagram shows a communication link within a group of friends. Use matrix N to record the presence or absence of direct communication. So, use the first letter of each name to label the columns and rows, and explain how the matrix can be read using the labels. That's okay, so let's go. I want you to set that one up. The Vicky, Stephen, Kathy and Paul. Let's set it up in a matrix. Now we're going to do, so what we're calling this is 1 step when you say who's directly. Okay, now they said to call it matrix N, so I'm going to say matrix N like that. And they said you can label it with their first letters. So Vicky, Stephen, Kathy and Paul. Vicky, Stephen, Kathy and Paul, as long as that order's the same. And then you just go through and we put in if you can connect with them. So Stephen can connect with not himself. Kathy can talk to everyone. Paul. Okay, so we've got the 1-step communication. why is this matrix symmetric? So first of all, we need to recap what symmetric is. So if I just highlight that, symmetric is if I put a mirror down that side, do the opposite, if that was a mirror, see this guy, if he was looking at that, wouldn't it look the same? Yeah? Can we see that? And then this looks the same as that. It's like you're looking in a mirror. So that's why do you think this matrix is symmetric? It's because if Kathy can talk to Stephen, Stephen can talk to Kathy, isn't it? Yeah? That's why. It's because if one person can talk to that person, they must be able to talk back as well. Okay, so that'd be why. So you might just write in there, why is the matrix symmetric? And just write because if one person can talk to them, they can talk back. If a person can talk to another person, it means they can speak. It means they can also talk back. So we might say communicate back, okay? And because of that, it ends up being a mirror image because you can do that. So the next bit, it says, what is the sum of column K? So if you look at that, the sum of column K, so if we add all them up, if we do that, so it'd be 1 plus 1 plus 1 equals 3. So what do we think if we added up the sum of column K? It's 3. What does that tell us? And what information is given by that? That means Kathy can talk to 3, can communicate with 3 people. Okay? So if you add up her column, can communicate with 3 people. We're telling the total that she can communicate with. All right, so we got asked to do that, and now we need to, it says n squared gives the number of 2-step communications, which we know that. So we're going to go and do this in the calculator. I want you guys to go give it a go, and let's have a look at what that is before we answer those questions. All right, so we've done that on our calculator and we squared it, and what we got was, I said 2, 1, 1, 2, 1, 3, 2, 1, 1, 2, 3, and 1, and 2, 1, 1, 2. Okay, so we've done that. And it says, namely, how many ways can one person communicate with someone else via a person? Find in an N2. So if you look about it, so this one for me was Vicky, Stephen, Kathy, and Paul. So let's do question E. Use this matrix to find the number of 2-step ways Kathy can communicate with Stephen. So where's that one? So we're going to E, and we're looking at, so you need to go to Kathy, and then we need to go to Stephen. So how many ways can they do it? How many is 2?
2.
Yeah, there's 2 ways to communicate via 2 steps. Via 2 steps. Okay, and if there, and then it said in the last one, if N2 matrix there is a 3 where the S column meets the S column. So here, where's S meets S? There's a 3 there. Okay, now that is on, and it explains how many 2-step communications Stephen can have with himself. Explain how this can be given. Explain how this can be given a sensible interpretation. So there's 3 ways. So you probably just need to, even though there's 3 ways, it could be adding a little bit of info as it goes through someone else. So let's just, for this one, there's 3, let's write out the 3 options that Stephen can get back to himself. So you explain it to me. So we want to start at Stephen. Sorry. We want to start at Stephen, go to someone, and who else, and then it would end up at Stephen. So who can he talk to? He can talk to. Where are the 3 options? It's probably going to be the other 3 people, isn't it? Yeah? Stephen to Kathy to Paul, and Stephen to Paul. Oh, back to Stephen, sorry. Back to Stephen. Okay? All right.